Bismillahirrahmanirrahim. For this morning, we will discuss about the one research article with the title Three Parameter Sujatha Distribution with Application. In the Rado Institute, we have discussed about one and two Sujatha distribution. You can join with the www.radoinstitute.com, and then you can come to the Bedah Research Article Tools. You can find the well explanation about the one and two Sujatha distribution. But for this time, we will discuss about the three parameter Sujatha distribution with application, of course, based on the best research article that published in the best journal, of course, international journal. And then in this program, we will support with the R programming to the makes easy to solve the problem in this research article. Okay, let's we check our research article. Okay, there is one research article that published in the European Journal of Statistics and the Probability in the October 2020 with the title A Three Parameter Sujatha Distribution with the Application. In this research article, there is a best explanation about the three Sujatha distribution. I mean, in this research article, there is information to understand about the how we can produce the three parameter Sujatha distribution. Okay. The three Sujatha distribution comes from the theory mixture distribution. There is three distribution. There are exponent theta. Exponent theta, we can say gamma 1 theta with the set equal to 1 and the scale parameter theta. Or we can say exponent theta equal to theta exponent main theta x. And then gamma 2 theta equal to theta power 2 x divided gamma 2 multiplied by exponent minus theta x, and the gamma 3 theta equal to 3 theta power 3 multiplied x power 2 divided gamma 3 multiplied by exponent min theta x, and then we use the weighted for the P1 or the first weighted theta power 2 divide the theta power 2 plus lambda plus theta, and the second weighted lambda divided theta power 2 plus lambda plus alpha, and the third weighted alpha divided theta power 2 plus lambda plus alpha. If you use the theory of the mixture distribution, of course, we will use this formula. This formula, we call that the theory of the mixture distribution. Okay, this is the theory of mixture distribution with the weighted one we have talks, and then this is the second weighted and the third weighted, and this one for the gamma 1 theta of exponential, and this one for the gamma 2 theta, and this one is for the gamma 3 theta. You can check here, and then we use the simple mathematics. We will find the density function for the three Sujatha distribution is theta power 2 divided 2 multiple theta power 2 plus lambda plus alpha multiplied by theta alpha plus x power 2 plus 2 lambda power x multiple x plus 2 multiple theta multiplied by exponent minus theta. So this one we call the three parameter Sujatha distribution. And then in this research article, the author give the some data to give the good example how to operate this distribution. There are 220 observation here. Okay, if we check the research article, there is some data here. 20 observation. Okay, this consists of the 20 observation, 1.1 until the 2.0. And then by the sum distribution, exponential, Akas, Santer, Linley, Amarendra, Sujatha 2 parameter and Sujatha 3 parameter. From the data, can you produce the estimate parameter using maximum likelihood? And there is some the theory for good of fit test, IC and BIC. Okay, this is all about the research article. Okay, now we can try to produce the art programming to solve this problem. Okay, we stop share our theory and we come to the our art. Okay, this is our art. In the art programming, we use the data, the 20 observation, like the research article say. In the research article, give the some data, start from 1.1 until 2.0. And then we use the theoretical for optimization, the log likelihood, three parameter Sujatha distribution. LL it means the log likelihood, the three parameter Sujatha. Okay, if you can check here, theta power 2 divide the theta multiple, theta power 2 plus lambda plus alpha, and then multiple by theta, alpha, multiple the x power 2, and then blah, 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 blah. It means the all is the density of the three Sujatha distribution. We just use the operation logs and the sum and then forget text minus here. It means you are use the log likelihood of the three Sujatha distribution. And then if you use the optim tools in the R, it means you are using numerical system to solve the equation. Of course, you give the some initial value. This is initial value for theta. This is initial value for lambda. And this one, the initial value for the alpha. It's very simple. It's very simple. Okay, let's we run our program. Start from the X until the optim. Okay, we run our program. Run. Okay, we check is the cancel. Okay, we have success to run the program. We can check the rest 0 to show the parameter. Caps lock, the rest 0. Enter. Again, you can check here. This is for the theta. This is for the lambda, and this parameter for the alpha with the convergent. Okay, it's mean we are success to the estimate parameter use the optim. Optim is mean the tools in the R. Okay, after we can estimate the parameter, we try to text one by one the parameter with the this program. Theta we call to risk 0, 1. You remember the double bracket here and then only one bracket. Okay, lambda use this program and alpha use this program. It means you take one by one, the all parameter here. Okay, you run here. Okay, you can check in your console. Okay, example, you can type theta here, theta. Okay, of course, you must find the theta parameter. Okay, after that, we must give the xi. Xi is the sequence 0 until the 2 power maximum data with the step 0.1. It means it's 0.1, the data will give you the information starting with 0 and then 0.1, 0.2, 0.3 until 2 power maximum data. We must give this information to make the good graph for the density of the three Sujatha distribution. You can check FF, it means the density, Sri Sujatha distribution, but you use the XI, not XY, because we are need a lot of point to make the smooth graph for the Sri Sujatha distribution. Okay, you can run here and LE is mean the log likelihood for the Sujatha Sri parameter. Okay, you can run here, you can run and you can check in the console. Okay. And then in this R programming, we give the sum R programming for the Amarendra distribution. Okay, this is all for the programs Amarendra. And then we give the theta Amarendra, log likelihood Amarendra, and XE. You must remember XE, this four produce the smooth graph for the density of Amarendra. And then is the Sujatha 2 parameter. Remember, we have the Sri Sujatha parameter, and for this one, 2 parameter Sujatha. This is programming for the Sujatha 2 distribution. We have the theta and alpha. We have the alpha and the theta. Okay, of course, we are give the parameter alpha for the theta 2 parameter for Sujatha 2 parameter, theta x for the theta Sujatha 2 parameter. And don't remember, don't forget we are use xi, the sequence 0, 2 power maximum data with the step the 0.1, and then this one the density Sujatha 2 parameter, we use a xi. You must remember this is to produce the smooth graphs. And then we give the ACAS. Okay, the ACAS distribution. And then this is programming for the ACAS. The programming to estimate the parameter with the maximum likelihood methods. And we give the parameter theta. We give the log likelihood the ACAS. And then this is the density for the ACAS. And then this is a good of fit test using the density plot. Okay, for the all audience in the home, like I said before, you can join with the www.radioinstitute.com. You can come to the tools of the Bedah Research article. You can find the well explanation about the Amarendra distribution, ACAS distribution, and then the Sujatha 2 parameter distribution. Okay, so the everybody need the programming. We will open with the slowly. You can check by yourself This is the X, the data, and then this one, the for the estimate parameter for the Sri Sujatha distribution here. Okay, we can take, okay, there is a long program. We try to open this slowly. We hope you can read here and you can use this program to the support your research here. Okay, this is the three parameter Sujatha, and this one the Amarendra. Okay, with the Amarendra, you can check the Amarendra here. This is all for the Amarendra. Okay, we can open slowly because the long equation here, long program, you can check by yourself here, and you can use to support, and you can use this program to support your research. Okay, this is for the Amarendra. It's very long equation here. Okay, this is for Amarendra. And this one for the Sujatha 2 distribution. Okay, Sujatha 2 distribution. Start from here until here. This is the Sujatha 2 distribution. Okay, we open this slowly. There is a one the long equation. You can check by yourself. This is for the Sujatha 2. These two the parameter. And the last one, we use the AKAS. This is AKAS. Okay. And then this is the, we try to open the density of Sujatha to distribution because the long. Okay. And then the AKAS distribution from here and then stop in here. Okay. This nice and the simple programming for the AKAS. You can check here, and then this is program for the density plot. Okay, our run the all our program here. We start from the X data. We run all until the AKAS distribution. Okay, stop here. We run our program. Okay, console. Okay, you can check here the program, the all program success to be run. It means there is no problem about the programming to estimate parameter for the three parameter Sujatha distribution, for the Amarendra distribution, and Sujatha two parameter distribution, and the last one for the AKAS distribution. Okay, for the example, if you want to find the parameter of AKAS, you just take the theta AK. You can copy here and then you can paste here. Paste, you can find, this is the theta parameter, 0.5. Okay, if you want to know about the log likelihood AKAS, you can copy the LAK, copy here and put here and enter, you can find a minus 47. This is a log likelihood for the AKAS. And then if you want to know about the parameter Sujatha 2 distribution, you can copy here. Okay, you pass and then you enter. This is a 4 parameter alpha in the 2 parameter Sujatha, and the second parameter theta x, you copy here and you put here. Pass. So there is the nice or the good programming here we produce to support this international research class. Okay, after we have found the all parameter, we run our the good of fit test for the full distribution here. Okay, we try, we run. Okay, we check here. Okay, if we make the analysis from this figure of the graph, no one model can the Fairfax to capture the histogram. But we can analyze the red one is the representative of the Sri Sujatha distribution. We can check here, the red one is can capture the histogram better than the others models. And we can check here, AKAS is the best one. Akas the best model for this research. For the black one is as representative Amarendra, and the blue one is the representative Sujatha two parameters. It means the Sujatha three parameters the best model in this research. Okay. After that, we can check the IC value for the all model that we use here. Okay, we can take the IC. Okay, we use here. Okay, we run here. Okay, we come to the console. Okay, for IC Amarendra, copy, paste here, enter. Amarendra is a 50x, and then Akas here, copy, paste here. Okay, this is for the Akas. Okay, and this Sujat, this is three parameter Sujata, copy, paste here. Okay, and then IC two parameter Sujata. Okay, we can check here. The smallest one is the Sujata three parameters. So we can conclude that Sujata three parameter is the best model in this research because the IC value is the smallest one from the other model here. Okay, I see we have success to discuss about this research article. We support with the art programming and we support with the well explanation about the research article. Okay, I think that's enough for this time. See you again in the next time. Of course, with the Rado Institute in the international research class. Okay, see you again and thank you very much.